Hello. I wanted to go over what a data mining project may look like. Alright, so in this presentation I will explain the steps involved in a data mining project and also illustrate these steps with an example. We want to start any project by defining a business objective, and so business objective, or you may have to define or refine a business objective as to why we want to do this data mining project and what is the objective behind it. Based on the objective, we will try and identify data that will be necessary for completing this project. And once you select the data, we will explore the data, see the distribution, the variability and relationship among variables and so on. We like to do some exploration. Based on the exploration, we may have to go back and collect some more data. And this process may go on for some time until we get a good set of data for further analysis. Once you got the data ready, we may have to prepare it and repair the data. Sometimes the data may not be in the right interval scale, or it may not be in the right scale, and we may have to clean up the data. Sometimes the distribution may not be the kind we'd like. I may have to do some transformation. So that leads to transforming the input data. And again, we like some data may be skewed, and we may not. Our technique may require that the data be normally distributed. So there are some techniques that can be used for converting non-normal data into more normal data. So those transformation steps may have to be done in the data mining project, and this process may have to be repeated over and over again for all kinds of data. And also we may actually create new columns, and the transformation may also involve creating new variables, and so that is also part of the data mining project. And then once we got the data all cleaned up and ready, then we may want to start building models, and we won't stop with just one model, but multiple techniques and multiple variations of each technique will be employed while building models. And we want to try and find which model or which models kind of do the best. And based on the models we build, sometimes we may have to go back and collect more data. So that again is something, it's an iterative process. You kind of go from, it's not like a single linear flow from one step to other. Sometimes you go back and repeat some steps. So once you got the models, and then we will want to see how good the models are. So that's to deploy the models, and we want to try and compare the models and see how good each model is in predicting and coming up with the right predictions. And based on that, we may have to build more models. Then once we got this, we'll want to try and assess the results of these models, and these models will then be compared with one another. The results of these models will be compared with one another, and then we'll kind of pick the best model. And we may have to go back and build more models also. And once we got the results, we would we may want to refine the project. The last three steps of deploy and assess, and also would mean that we actually employ the model in our decision making and then see how good the results are. So that is also an assessment part. Okay. All right. And so a data mining project is a good part of the data mining project involves actually building up the data set, and so setting up the data set and also doing the data investigation and cleansing the data. There may be missing values, there may be incorrect entry, there may be some outliers, there may be spurious wrong data, and you must be able to get all that cleaned up. And sometimes you'll have to do some aggregation, grouping data on some characteristics and coming up with summary values and use those summary values and some analysis. And also we may want to see if the data itself or the input variables are kind of related to one another. So there's something called autocorrelation. We may want to try and identify and do some cleanup based on that. And also some data may not be in the right distribution, and we may have to do some transformation to bring it to a correct distribution for analysis purposes. And the models that we use must be actionable. In other words, the model must be able to tell us what is the probability of an outcome variable will take this particular value. So based on the probability, we must be able to either take some action that can be prevented, and then it must be measurable. And the models that we choose must make consistent and reliable predictions. And so that, again, we're going to be coming up with multiple models and then pick the best model. All right, now best model based on how good it is in making consistent and reliable predictions. And there is a sort of a method that SAS has implemented in its tool called SEMMA, S-E-M-M-A, and so this is an acronym, of course. And so it stands for sample the data, explore the data, modify the data, create models, and assess the models. So again, for all these steps, SAS has tools, or SAS has features which let you do that. Now the example problem we look at is at a university setting, and the university administration wants to increase retention rate. And so retention rate meaning like people who joined the university, and we like them to come back and enroll in classes the following semesters, and also finally graduate from the college or the university. So we don't want people to drop out in the middle of the program. So retention rate is an important metric for any university. And so there is an office called Office of Institutional Research, and they've been tasked with coming up with a recommendation for addressing this. Now recommendation would be like things like early intervention, or maybe in helping the student get oriented better, or maybe having better campus life environment, or maybe one-on-one counseling with the department, or things like that. So in other words, they want to be able to make some recommendations so that the retention rate can be improved. And so how will they make those decisions is to build models that will predict those students who most likely are not going to return in the following semester. So based on past data, they want to see, there are some students who did not return, so what is special about them? What kind of flags were we seeing for those students, and can we identify those flags? So that is the first part, is to build the model. Okay, and now they have data on students who enrolled in fall of 2012, and data on students who came back in 2013. And of course, then all students who enrolled in 2012 fall would not have come back in spring of 2013. So it means some students dropped out. So we want to try and build a classification model, and so then once we got the model figured out, then we'll try and look at the fall 2014 enrollments, and then identify students who are at risk of not coming back, who are at risk of dropping out, and then do some preventive actions so that those students who are predicted not to come back will come back and complete the program. Now, of course, to do all that, there's going to be a whole bunch of expertise needed, and you need to have expertise in the domain, which is like higher education. So you must know information about enrollment, and how admissions are done, and how retention office works. And so you may have expertise. You will need expertise from these different domains. And also, since it involves collecting data from multiple sources and so on, you must have access to expertise on database administration as well as data entry. And so we're talking about building models, so you must have some people who are good at using programs like SAS. So you'll need people who are the analysts who will build SAS models. So you need to kind of rope in expertise of all these people. And of course, sometimes a project like this will involve people from all these different areas. Alright, so let's look at the project a little bit up close. And so the idea is we want to improve the retention rate of new freshmen who will enroll in the university, and we'll begin by building retention models to identify those students who are at risk, who are most likely not going to return the following semester. And so then we'll use it for the first model for scoring those new freshman students who entered fall and are currently also enrolled in 2013. So we will come up with some measure of how good the models are by calculating the score for those students who came back in spring 2013. And then we will so we'll start with looking at the data of students who enrolled in fall 2011 and also who continued in spring 2012. Okay, and the target variable will be defined by students who enrolled as well as who did not enroll in the following fall semester. Okay, so target will be either 0 or 1 for those who did not enroll and 0 for those who did enroll. So we create a target variable, and the project team will then identify inputs that are needed for the prediction. And so they may include things like demographic data, financial data, student life, and grades, and other information. Once they they'll use all this data for in the model, and what classes the students took, what grades the students got, how large these classes were, what level of classes these were, and then demographic data may be things like students' zip code, income, family income level, the other information about the student's home, and information about whether the student's parents had college degrees. Those kind of things may also be relevant. Demographic data, financial aid data may be whether the student has to be working also when in college to support his living expenses, and information on students' admissions and so on. And also there may be some calculated inputs. Once we got all this data brought in, then we look for patterns in this data and look for extreme values, unusual values, values that seem like outliers, that are very far away from the mean, and also there may be some variables that may have direct relation to target variables, and look for records with missing values. And sometimes there may be a relationship among the input variables, so this is called auto-correlation. So you may want to try and find all those things during exploration. And then while doing exploration, we want to fix all the problems. And also, then if your data set involves multiple tables, you must be able to join them. And so make sure there are fields that let you join based on this foreign key and primary key kind of information. And so that joining will not be an issue. The next step is to transform the data. Again, once we got the data created, once we got the data cleaned up, we may want to create new columns. Examples may be distance from home to school and the age of the student, whether the student is working or not, 0, 1 kind of a thing, and some kind of a indicator on transcripts such as GPA, and whether the student is in probation or at risk of probation, and those kind of things. And also information on what proportion of the students in that major actually graduate, so major rate, and what proportion of students from that student's high school continue to finish college, so maybe high school rate. and what proportion of students who are in dorms, that may be variables. So in other words, we can create all these variables from existing columns. The next thing is to we can use SAS to create these new columns or transform these input variables. And sometimes you may want to make sure the distribution is symmetric, and there are ways to do that. So there are some transformation that can be employed, and we'll do that transformations. And also sometimes you may collapse, there may be you may have 10 different levels of a categorical variable, and that may be too many, so you may collapse it to just 2 categories or 3 categories, and those kind of things can also be possible. And so a lot of times just getting the data ready will take a lot of project time. And once you got the data ready, and then SAS's enterprise miner can be used to build the decision tree models, logistic regression models, and so on. And once you got all these different models to predict the outcome variables, then we can see which is the best model, and we can have some assessment statistics done on each model, and then choose the best model. Then once you got a best model, then we will then apply the best model to score a new data set such as fall 2012. Then we'll see once we got this model figured out, we'll apply this model to data from fall 2013, so that we can predict who will be at risk of not coming back the following semester, and then take remedial action. And so then once you got the list of students who are at risk, then we can share that information as to what are the things that can be done to make sure those students will come back. All right, so that's the whole process of the project. And of course, after having done this, we want to see if the students actually came back, those students for whom we intervened and did employ the results in a positive manner, whether that had any effect or not, that can be assessed. So that's last step. All right, now of course the time needed to complete all the project is kind of really hard to predict. All right, so originally data preparation, you might think it takes only about 10% of the time, and analysis 90%. That may be the projected. Actually, data preparation may take 80% of the time, and we have only 20% of the time available. But sometimes it may so happen getting all the data in may take a huge part of your project time, and so the actual time needed can be actually twice the amount of time you originally thought it would need. So it is sort of problematic, but there are ways to manage that. All right, and so that's the end of this presentation on data mining project. Thanks.